Good day, everyone, and once again, we are back together. Your favorite uncle is with you again, giving you good content on maths and physics. All right, so today we are going to look at the Mpumalanga. We're continuing actually with the Mpumalanga paper. Of course, this was written during prelims. So if you haven't subscribed, please just make sure that you are part of the family. All right, and just make sure that you share and like, the video at the end of the day. Okay, or rather after watching it. Okay, and of course, you're more than welcome to get in touch with us. All our information is found, on the description of the link of the video. So you are more than welcome to get in touch with us. All right, now without any further ado, let's just get right into the question. So this is based on vertical projectile motion. They say ball A, which has a mass of 0.01 kilograms, is dropped from point P, right from the top of a hill, which is 57.5 meters above the ground. At the instant that ball A passes a point Q, right, which is 16 meters below point P, a second ball B of mass 0.02 kilograms is thrown downwards at the same height as point P, right? And in this case, they say both balls reach the ground at the same time. All right, now we want to now find out, is ball B in free fall? Choose yes or no and explain the answer. So remember, in this case, the moment that we throw ball B, in this case, remember that it is moving, the only force rather that is acting on ball B is gravitational force. So as a result, because there's no air friction, in this case, gravity is the only force that's acting. So therefore, yes, it is in free fall. Okay. Now the second question, they say to us in 3.1, calculate the time it takes ball A to reach point Q. Now remember, ball A started from P, and in this case it went to pass Q, which is 16 meters below, right? So in this case I'm going to take from P to Q, right? So let's take information from P to Q. All right, this is from for ball A. Okay, so what do we know in that case? We know that the initial velocity, remember what they said about A, they did say that it is dropped, right? So that means that the moment we see that it is dropped, so that's something we just need to make a note of in this case. So it means that we know that the initial velocity will be 0, right? So in this case, we know our initial velocity is 0. We don't know what the final velocity was at point Q, but we do know, by the way, we need to choose a positive direction. So I'm going to take downwards as positive if you don't mind. So what this simply means is that for all the questions that we're going to answer, we're going to take gravitational acceleration as positive 9.8 meters per second squared. Please remember that gravity always acts downwards. So even if the ball was going up, if I've chosen down as positive, it means that we will still retain that gravitational acceleration as positive because it acts downwards. Right, so we don't know how long it took. That's what we are looking for. But we do know the displacement, in this case, delta y, right? The displacement, the straight line change in position between those 2 points, it went 16 meters downwards, right? So in this case, it means that will be positive 16 meters. Right, now keep in mind, they did ask us to calculate the time it takes, right? So which equation of motion? Now, I want you to note, we are looking for the time, okay? And in this case, what do we not have? We do not have the final velocity. So which equation does not have final velocity? Of course, we're going to say, well, it's VF squared. Actually, that's not the one. It's actually delta y I know in your exam it's written, or in your data sheet is actually written as delta x, right? So because it's vertical motion, I'm going to retain it as delta y. So delta y is vi delta t plus 1 over 2 times a delta t squared, right? So our displacement in this case, that's 16. Let's substitute all that we know. Our initial velocity, remember, that's 0, so it's making this entire term become 0. So that's a half of, our a is 9.8, positive 9.8, and we're looking for time. All right, so half of 9.8, that's going to be 4.9 delta t squared, which is equal to 16. So we'll divide both sides by 4.9. And in this case, what we then find, so let's try to, okay, get that there, divide by 4.9. Okay, that gives us 3.2. And then remember, we take the square root of our answer. Okay, so that means that it only took 1.81 seconds. Okay, so that's the time it took for ball A to move from P to Q. Right, now the next question, they say to us, initially, or rather calculate the initial speed of ball B, right, with which ball B rather is thrown downwards, so that both balls reach the ground at the same time. Right, now I want you to please be mindful of the following. Right, now remember, at the time that we dropped A, right, so if we say this is going to be ball A, right, so we know that ball A would have moved, or rather would have been 16 meters below, right? So it's 16 meters, the difference there. But at the time when ball A was 16 meters below, then we threw, remember, we are giving this guy an initial velocity, right? And that's exactly what we're looking for, because they said the initial speed with which we throw it, right? So in order for them to reach, the ground at the same time, in this case, it means this one, we must now give it an initial velocity, okay? Right, now, remember there is also a time delay, right? So what I'm going to do is, let me find out how long it took for ball A to actually reach the ground, okay? If I can find out how long it took the ground, remember, how long would it have taken ball B? It would have taken that time that A takes minus that 1.81 seconds, because remember, that's the delay that ball B had in that case. I hope I'm making sense, right? So what I'm going to do is say, right, let's find out the time that it took, and remember, the height from where ball A was thrown up until the ground is 57.5, okay? So in this case, let's deal with ball A first. So I'm going to say, right, for ball A, right, we knew that the initial velocity is 0. This is now between we said that's point P, right, to the ground. So this is between P to the ground. Okay, so in this case, we don't know what the final velocity is. And ladies and gents, I want you to quickly give you a warning. Please remember, when we're talking about the final velocity, we are not referring to when it actually touches the ground, because the moment that it touches the ground, it is no longer under projectile motion, or it is no longer in free fall, because gravity is not the only force that's acting. The ground is actually exerting a force as well, right? So it means that the final velocity we are referring to is the velocity just moments before it touches the ground. So we don't know that velocity either, but we know that gravitational acceleration is 9.8 meters per second squared. We know that the time, or rather, we don't know what that time is, but we do know what the displacement is, we said that's going to be 57.5. I think that was the displacement. Yep, it is, right? So that's 57.5 meters, right? So what we can do now is calculate the time that it took, right, for the ball to actually reach that point there. Okay, and I'm sure you can see that we're going to actually use the very same equation, delta y vi delta t plus 1 over 2 a delta t squared, and in this case that's going to be 57.5, which is equal to, again, this is 0 plus 1 over 2 times 9.8 delta t squared. Okay, so that's going to be 4.9 delta t squared, which is 57.5. Okay, I'm dividing by 4.9 on both sides and taking the square root. Okay, let's do that. So that's 57.5. We're dividing by 4.9. Okay, and in this case, we're going to take the square root of our answer, and I get a time of 3.4, well, let's say 3.43 seconds, right? So now, I want you to note, ladies and gents, now when it comes to ball B, right? At the moment that ball A was actually 16 meters below from where it was dropped, then we released ball B. So how long would it have taken? It took 1.81 seconds to get to that point. So meaning ball B had a time delay of 1.81 seconds. All right? So how long will ball B actually take to reach the ground? It will be that 3.43 seconds minus the 1.81 seconds, right? So what we're going to do is the time is 3.43 minus 1.81 seconds, and that gives us 1.62. So now we're dealing with ball B. We want to know what the initial velocity is. The final velocity we don't know either, but we know gravitational acceleration is positive 9.8 meters per second squared. The time that it took, remember, we said that's going to be that 1.62 seconds. So 1.62 seconds. And we know it would have been displaced as well, a positive 57.5 meters, right? So in this case, once again, we're looking for the initial velocity. We do not have final velocity, right? So the only equation without final velocity, well, funny enough, ladies and gents, we're still going to use the very same equation because that's the only one without final velocity, right? So we're going to say, well, again, delta y, that's vi delta t plus 1 over 2 times a delta t squared, right? So our delta y value, that's 57.5. Okay, and initial velocity, that's what we're looking for. The time was 1.62 that it took. That's half times 9.8 times 1.62 squared. All right, now I'm going to obviously find this entire term, take it to the other side. So it's going to be 57.5, and I'm going to subtract that entire thing there. Right, so I'm going to say 57.5, and I'm trying to also show you, ladies and gents, that you need to be very efficient when it comes to the usage of your calculator. You don't get marks for dragging this thing out, right? So that's minus 0.5 times 9.8 times 1.62 squared. Okay, so I get 44.64. So what this simply means is that we've got 44.64, and this is equal to VI times 1.62. Of course, what are we going to do? Divide both sides by 1.62, okay? And now find our initial velocity. So I'm going to divide by 1.62. In fact, yeah, let me not make a mess of that. Okay, divide by 1.62. Okay, so I get an initial velocity of 27.56 meters per second. And of course, we know this was downwards, right? Let's see, did they say calculate they said the initial speed. So in this case, direction doesn't really matter. Okay, right. Now, they say to us, the next question, calculate the speed of ball B just before it hits the ground. Okay, so we are looking at ball B, all right, which is this guy over here. Okay, we're saying, look, we're looking for the final velocity. I'm not going to waste time. I'm going to use the easiest equation of them all. So I'm going to simply say VF is VI plus A delta T. You know, it always helps to know these formulae off by heart, you know. But of course, you do have the data sheet in front of you. But of course, the more you practice, you know, the more familiar you become with these, you know, with the formulae, right? Remember, formulae is plural for formula, right? Please don't think that I'm saying something that's incorrect, okay? Right, so VF, all right, we're looking for the final velocity. Now we know what our initial velocity is, right? That's 27.56 plus 9.8 times 1.62. Of course, you could have used the other formula, in this case, you know, VF squared and so on, right? So we're going to say 27.56 plus 9.8 times 1.62. Okay, so we get 43.444. Okay, so that's 43.44 meters per second. All right. And by the way, there was no avoiding using that initial velocity. You'll see every single one of the equations does have initial velocity in them. So in this case, you just had to use it. Okay. Right. Hopefully, ladies and gents, you can still follow in what I am doing. Right. So let's go to the next question. Actually, I should actually number these questions, eh? So we started with 3.2.1, okay, and we had 3.2.2, which was this one over here when we're looking for the initial velocity. So it started here, 3.2.2, and this was 3.2.3, right? Okay, so let's go on to the next question. Now, they say ball B is in contact with the ground for 0.02 seconds from where it bounces back with a velocity of 20 meters per second, right? They say to you, calculate the force that the ground exerts on ball B, right? Now, what's going to happen there is that remember, once ball B touches the ground, there are two things that happen there, okay? So it means that upon impact, right, ball B obviously exerts on the exerts a force rather on the ground, right? But the ground exerts an equal but opposite force on, you know, on the ball, right? So now what we're going to do is simply say, right, we can actually use the impulse momentum equation, right? What you need to remember is that they said to us the ball bounces back at 20 meters per second. So it leaves the ground at 20 meters per second. But remember that it reached the ground at 43.44 meters per second. Now, ladies and gents, this is the part that I really want you to be careful of, because this is where the sign actually matters, right? So remember, we had chosen down as positive, right? So what this simply means is that at the time when ball B reached the ground, it was moving with a positive velocity, right? But in this case, as it leaves now, of course, it's actually negative 20, right? It actually does even show that you've lost some of that momentum there, obviously due to the collision taking place. So I'm going to say, so it's F net delta T, which is equal to the change in momentum, right? So we are looking for the force that the ground exerted. Now remember, in this case, they did say the time, I think it was 0.2, 0.02, and the mass, by the way, of ball B is 0.02 kilograms, right? So in this case, that's 0.02, that's the time. And remember that the change in momentum is mass multiplied by the change in velocity, right? Meaning that it's going to be mass times final velocity minus initial velocity. So I'm going to substitute that there. So that's 0.02 kilograms, right? Our final velocity, remember now, when it comes to the collision, we're talking about the before and after. So this is the, the velocity before, and that would be the velocity after the collision, okay? So in this case, our final velocity is the time, or rather is the velocity after the collision with the ground. So that's going to be negative 20, right? Minus, now remember there's a minus sign there, minus a positive 43.44. So that would be 0.44 there, right? Let's just remove that. So in this case, what do we have? Right, so of course we're going to divide both sides by 0.02. What we do on the left, we do on the right. Okay, but we can see that cancels that. Okay, so the net force, right, so in this case I'm just simply going to say that's minus 20 minus 43. Actually, it's embarrassing that I'm using a calculator there. So that would be minus 63.44 newtons. Now remember, why is it negative? Right? Remember that the force that the ground exerts on the ball is actually an upward force in that case, right? So they said calculate the force that the ground exerts on ball B. So it is a force upwards. Okay, so the ground exerts 63.44, right? So that would be 63.44 newtons, and it is a force upwards. Okay, right. And then finally, they said to us, write down the acceleration of ball B when it moves vertically upwards. Now remember, ladies and gents, right, that as soon as it leaves the ground, again, it is in free fall. So it means that the acceleration is the acceleration due to gravity. It is 9.8 meters per second squared, and in which direction it is downwards. Please do not make that mistake of thinking that now that the ball is going upwards, then it means acceleration is upwards. Remember, gravity always pulls us towards the center of the earth, and in our case, it is always downwards. All right. Hopefully, ladies and gents, that was really helpful. Okay, I hope that you enjoyed. It was really, really a lovely question. I think that as we prepare towards the prelims, it's really going to help you to master this section. All right. Now, obviously, I would like to appeal to you, to always keep in touch with us. Please make sure that you, share and like, our channel, our videos. And please just tell as many people as possible about the good content that Uncle Mlu is always dishing out. Otherwise, from me for now, I'll see you guys again next time. Sharp, sharp.